All right, today we're going to be looking at section 6.5, properties of logarithms. We're going to be working with properties of logarithms. We're going to write them as an expression with the sum or difference of logs. We're going to write them as a single logarithm, and we're going to evaluate them when their base is neither 10 or e. So in this first part, I feel like some of this should have come beforehand, but we're showing you that log with any base of 1 is equal to 0. And they kind of show you that by changing the log to an exponential expression. So remember, you take the base, you move it over, it becomes the base, and that becomes your exponent. So a to some power equals 1. And by properties of exponents, we know that a to the 0 power is equal to 1. So they rewrite it like so, and you get to see that y equals 0. So that's one property. Very important, so remember that. And we have another property. It's kind of like the cancellation property. Log of any base, if you're evaluating that same number as the base, it's kind of like they cancel each other out and just end up with 1. It's almost like dividing out. So again, when they change this to exponential function, they kind of show you, bring that base a over, and then y becomes your exponent. So a to the y equals a to what power? And it's understood to be a 1. So you get to see that y equals 1. So these are two important properties of logs. In this property, we also see the same thing. It's also kind of like a cancellation property. If you have base a and then you raise it to the exponential power log base a, again, the same thing happens, that base a and this log base a cancel each other out, and you just end up with whatever term you were trying to evaluate and find the log of. So m was that term, so these terms cancel out and you're left with m. And the same thing here, log base a, the a and a log a cancel each other out, and you're left with whatever you're trying to evaluate. In this case, the power of that base. So they both work out pretty close to the same. Very important properties and easy to manipulate whenever you need. Now, these are the other properties that we'll be looking at whenever you have log of some base, any base, and you're multiplying two terms together inside of that log. You can rewrite that expression as two separate logs with the same base and addition in the middle. So multiplication of logs translates to addition of logs. So you have to make sure the bases are the same. The difference quotient, so quotient equals difference. In the same aspect, if you have some log and you're dividing two terms, those turn into subtraction. So the top term minus whatever's on the bottom. And then if you have log of some base raised to a power, that exponent can be brought down to the front and multiplied as a factor. So product equals power. So you take that power, the exponent down, and bring it to the front, and then you just multiply it. So those are the same. And then this right here, we're seeing the same concept. This would be like if you were to take that base and move it over. You would a to the r can be rewritten in this form. That one's a little bit different than some I've seen before. I had to study that one a bit. Natural log of both sides, you can rewrite it. But I guess basically what you see is if you were to take that power of r and put it back up here, because you can move it back and forth, you would have ln of a to the r, and then ln has an understood base of e, so that e and ln would cancel each other out, and you'd be left with a to the r. So that's the idea there. Look at that one for a moment. Okay, other than that, I think they just show you some examples, which we will do in my math lab. So you'll be combining and using all those properties to rewrite logs. This is just if m and n are equal, then the log base a of m is equal to log base a of n. That would be the same. And I think this is saying the same thing. If these two are equal, then m and n are equal. We should see a change of base. Yeah, here we go. This is the last thing. Change of base. So in your calculator, you can do, depending on which one you have, if you have an 84, and it tells you right here, you can do change of base, and it kind of talks about how you can do that. But if you have an older 83, you can't change the base. You have to use whatever base is given. So the way you do that is we can say log, and then whatever you're taking the log of on top, and it can be any base, and then you do the log divided by that log of whatever that base was on the bottom, and you have to use the same base you use for the top. These two expressions would be equal. So I could put a 10 here where b is. I could put a 2 here. As long as whatever I put here is the same, then this expression is equal. And so this, again, just showing you the same thing. And it also works with natural log as well. You can take a log and do natural log of whatever you're taking the log of divided by natural log of whatever the base was. So it works either way, as long as you use the same on the top and the bottom. And I think that'll be the last property that we see. Yeah, here's the overall summary. So these are all the things we're going to be using. And so from here, we're going to go ahead and jump into Hawks.